I am your guest host, Edward Dowdye. Today we shall discuss Eddington's solar eclipse observation of May 29, 1919. Einstein has stated, if one of his three central proofs were determined to be wrong, his entire theory would collapse, as you can learn in this article. In fact, all three of the observational proofs which Einstein had advanced can be shown to be invalid. Eddington was concerned with gravitational lensing, the belief that rays of light bend near the sources of gravitation. The greater the gravity, the greater the bending. The further from the source of gravity, the less the bending. By measuring the position of a star before an eclipse and during the eclipse, Eddington could discern if the sun's gravity bent the rays of light. But in fact, unlike what was expected, light only bent at the limb but did not bend above the plasma limb. Modern technology in astronomy can measure the relative position of the stars, allowing introduction of a new term, the solar plasma focal length, shown in this figure. Emissions from extragalactic radio pulsar sources, which are primarily microwaves, deflect around the solar limb at the angle of precisely 1.75 arcseconds. Considering the value of the solar radius, microwaves deflected by the sun should come to a focal point at the distance of 560 astronomical units. An astronomical unit is the distance from the sun to the earth, or 8.3 light minutes. Another star of the same radius and mass of the sun should have the same focal length. Let us say that electromagnetic waves are deflected by an arbitrary star of mass m and radius r. The arbitrary star will have a plasma focal length given by this equation. This is simply the application of a ratio comparison between the radii and the masses of the sun and of the arbitrary star. For instance, a star twice the mass of the sun will have the same radius of the sun, will have a plasma focal length of 280 astronomical units. Since this hypothetical star has twice the mass but the same radius, it has more density. Therefore, denser stars will have shorter focal length, while less dense stars will have longer focal lengths. These observations are true only at the plasma limb. Light bending has not been observed further from the sun, even though gravity should still be bending the rays of light according to general relativity, albeit less strongly. If the light bending rule of general relativity were valid, suggesting a direct interaction between gravitation and electromagnetism, then it should be difficult to see the stars in the sky, as light would look distorted, blurred, and filled with Einstein rings and arcs caused by gravity. In the central sense Eddington's measurements, we have never once observed a true Einstein ring. Why is that? First, we have covered that the plasma focal length of the sun is 560 astronomical units, or 3.23 light days. The closest star is Alpha Centauri C, a full 4.22 light years away. Therefore, the plasma focal lengths of the stars are too short for us to observe from Earth. According to Einstein, only light bent from much further than the star's radius would have focal lengths long enough to be observed as Einstein rings. However, the fact that we don't see true Einstein rings in astronomy implies that it is not the gravity of the star that causes the light bending, but the plasma atmosphere directly above the star's surface. We can easily make this argument with a minimum energy path or a least time path calculation. Such calculations demonstrate that microwaves are deflected only at the angle of 1.75 arcseconds relative to the solar plasma limb. They are not deflected above the plasma limb in empty space. If all deflections of microwaves actually occur only at the plasma limb and not significantly above it, this would clearly be a direct violation of the solar light bending theory of general relativity, as you can see in this figure. Moreover, the theoretical calculations result in a derivation of the very same light bending equation that was obtained by assumptions of general relativity. But this time, they have nothing at all to do with general relativity. The minimum energy or the least time calculations are based on a conservation of energy and momentum theory of the ionized plasma moving in the solar limb, exposed to the gravitational gradient field of the sun. The gravitational gradient field acts on the solar plasma limb, and the solar plasma limb acts on the electromagnetic waves as shown in this equation for the angle of deflection alpha in radians, where m is the mass of the sun, c is the speed of light, and g is the universal gravitational constant, and eta is the radius of Gaussian sphere that encloses the mass. The sun's gravitational gradient field acts indirectly, not directly, on the electromagnetic waves deflected from the extragalactic radio pulsars. What is interesting to note, this effect has been found to be completely independent of the frequency of the waves being deflected at the solar plasma limb. You can learn more in this paper. In closing, I hope that you enjoyed this brief discussion of the bending of electromagnetic waves at the limb of the sun. Phenomenon has nothing to do with general relativity.